think we're live. We're live.
Okay, sweet.
So this week we're doing lesson 9, correct? Yeah.
Yeah.
How was the individual prep for you?
It was good.
Any
Yeah.
questions or anything?
No, not that I remember.
No. I'm pretty good on it too. Wait, give me 1 second. I just want to check something. Sorry. So you have any questions on the individual prep thing?
No.
No.
Do you have any questions?
I think why won't it open? I'm opening it right now, but it won't open. Okay.
Is your quiz loading?
Yeah, it's slow for some reason. It's like really slow.
Yeah, same.
I don't know why. I mean, this is being weird right now. So no, I mean, oh, but we're supposed to do number 1, number 2 with the group though. So
Okay.
so which is easy. It's just about the no and the alternative. So the graduate management admissions test, the GMAT, is used as admissions criterion for many masters of business programs. The scores of the GMAT in the past have a mean score of 529. The UI professor feels now that the score has improved within the last couple of years.
I spell forgiveness.
Determine the no and alternative.
RGIVENESS. Just
Giveness.
one. Yeah.
Okay. So determine the no and alternative. I think it's pretty simple. The no is always equal. So it'd be no. The population mean would be 529 because that's the mean score. Since the BYU professor feels that the score has improved, the alternative would be the mean score is greater than 529.
Yeah. Yeah, that's right.
And number 2. Want to read number 2? Hey. Okay, sorry. So number 2 is, it says, suppose you got evidence that the no hypothesis should be rejected, so rejecting the no. However, in reality, the mean score of the students taking the exam is still 529. So the mean was rejected. No. The no was rejected, but the reality is the mean is still 529, which means the no should be accepted. So was that a type 1 or type 2 error? So type 1 error is when we reject the no. Assuming the no is true. Type 2 error is okay. So type 1 error is when the truth is the no. It's when the no is true, but we reject the no. Type 2 error is when the alternative is false, but we fail to reject the null. So in this case, the null would be true. It would be a type 1 error.
Yeah, but we rejected it.
Yes. So
It's
it,
1.
yeah, type 1 error was committed since the null is true and we rejected the null.
Yeah.
If the analysis was done at what is the probability of committing a type 1 error? So if the analysis was done at 0.01 significant level, what is the probability of committing an
Thank
error?
you.
So 0.01 level, that's the same as 1%.
0.01? Yeah, it's 1%.
So it'll be 1%. 1% error. If we wanted to decrease the probability of making a type 2 error, what would we need to increase or decrease the level of significance?
Go on
Decrease.
to.
What do you think?
If we wanted to what?
If we want to decrease the probability of making a type 2 error, do we want to increase or decrease the level of sig?
Increase. Wait, decrease. Because type 2 is when it's wrong, but we say that it's not.
Type 2 is when the truth is that the null is false. So the null is false, but we fail to reject the null.
Yeah.
The null is false, so we fail to reject the null. Which means
So if we wanted to decrease the probability.
we fail to reject the null. The level of significance is reject the null. That does not depend. We need a number that can. The level of significance is the number that's used to see if the p-value is small enough to reject the null. So reject the null. In every case, we should choose a large computing p-value. I think it would be increasing the level of significance.
Oh, significance.
Yeah, because the level of significance is the number that's used to see if the p-value is small enough to see if it's true. If it's like if the null is true or false, right? So if we increase the level of significance, that means it'd be more likely that that is true. Wait.
Yeah.
No, it'd be more likely that false. I don't know. I'm just I don't know. I'm just thinking in my head right now. I'm so confused.
So if we increase the significance of it,
Mhm.
wouldn't it be more likely that we would know whether it was true or false?
Yes. So, but we want to decrease. No, you're right. Because if we increase the level of significance, we'll decrease the probability of making the error.
Yeah.
Because we'll know the numbers.
But if you
We'll
want a
know
type 2 error, you have to get it. You have to
increase.
not do the right thing or whatever.
Okay. Okay. That's fine. Okay, are we good?
Yeah.
Okay, let's just go to the quiz. Okay, 1 true, 2 true. A hypothesis test consists of 2 hypotheses, the null hypothesis and the alternative hypothesis. Which ones represent the status quo? The status quo is always the null, because the null is like the equals to.
Yeah. And then which hypothesis involves the equality is the null. It was the inequality one.
Yep. 3. It's easy. The p-value is probability of obtaining a sample of statistics at least as extreme as the one that was actually observed. When computing this probability, which hypothesis do you assume to be true? You always assume the null to be true because the null is the status quo, so it's like the go-to one.
Yeah.
Like, yeah, it's like the basis one. So yeah, right, yeah.
So the null. Yeah. Suppose the null hypothesis h equals u equals 10. Which of the following represents the alternative hypothesis for 2 deltas? Well, then it'd not be equal because nulls are the equal ones. So it'd be D, right?
Yeah, because it can't be C because that's the null. And I think for a two-tailed would be they're not even. They're not even on the two sides.
Yeah.
So they're not symmetrical. So you can't really determine like if it's greater than or less than. So I think you're right. I think it's the not equals to 10. Which of the
And then
following?
the next ones ask about left and right. If it's left,
If
it's
it's
less than.
left, then it's less than because
And if it's right, it's
greater
more
than.
than.
Yep.
Like this. It's left. It's less than. Right. It's more than.
Okay, so the outcome of a hypothesis test is determined by comparing the p-value to the level of significance. Which relationship would result in failing to reject a null? So, in failing to reject a null, fail to reject the null. Wait, fail to reject the null is the null is true, right? Right?
Yeah, that's right.
So if the null is true, then that means the p-value is greater than, what was it? It's like 0.6 or 0.06, something like that. So it means it's greater than the level of significance then. So the p-value has to be greater than.
Yeah. It's for question which result in
So the
failing.
p-value is greater than alpha
Yeah.
because you fail to reject the null, right? So the null is fail to reject the null is true.
Yeah.
Okay.
Yes.
So which means the opposite would be the p-value is less than alpha.
Yeah.
Yeah.
And failing to reject and then rejecting.
What's up? Okay, next one, please.
Insurance company is reviewing the current policy rates when originally setting the rates. They believe that the average claim was 1,500. It was actually higher than this. C. It says it right in the question.
Yes, you're right.
Because they think it's higher, so
Yeah,
the
you're
average
right.
claim amount is greater.
Yeah. Which of the following would be the appropriate null? So the null would be equals to 1,500. Right? Wait. The null would be, yeah, equals to 1,500.
Wait, why equal?
Because the null is always equal. Wait.
Oh, yeah.
Yeah, the null is always equals to. That's always the null. Usually, yeah, that's always the null.
Yeah. Okay, that makes sense. Okay, the insurance company randomly selects 40 claims and calculates a sample mean of X. 1650. Assumes the distribution.
What do you think for number 13?
I'm reading it right now. Randomly selects 40, calculates a sample mean of 1650. The insurance company says. Yeah. Yeah.
Me too.
I mean,
Um,
you'd probably assume anything is normal
yeah. Well, it's not just that. I think
until
it's
something
because
tells you
remember
not
it
to.
n is greater than 30, and if n is greater than 30, it's always normal, even if
Yeah,
it's right.
because then it's big.
Yeah.
Yeah.
What theorem or law justifies your answer to the previous question? Well, since n is greater than 30, that means the sample size is large enough that the distribution is normal. So that would be the central limit theorem, I believe.
Yes.
Yeah. Because the law of large number deals with more of like I think the sample mean and the population mean. Which of the following is the test statistics? The test stats would be, what do you think?
Is it cold in here or is it just me?
I think it's just you. So which of the following test stats? Wait, let me look. So the blah blah blah. We need to determine how far the sample mean is from the population mean. Since we know sigma in this case, we can use the z-score to determine that value. This is called the test statistics. So it'll be z's because this is a z-score. Be z. So B.
So that is.
It'll be a z-score, so Z. Historical mean of sales received at a grocery store is 150 with standard deviation of 40. The store manager suspects that the average has decreased. She set up a hypothesis test with the hypotheses that no is equals to and alternative is less than. Use the level of significance 0.05, then take the simple random sample of 36 sales receipts. Computes the sample mean. What is the z-score associated with this test? Z-score. Okay, it's just a z-score calculation. It's. All right, you want me to do it?
I'm doing it right now too.
Oh, you are, okay. So it's just the it's the 144 minus 150 over 40 divided by a root of 36. Okay.
And I got negative 0.9.
You got what?
Negative 0.9.
Let me do mine real quick. Um, Yep, negative 0.9. That's what I got.
Okay, negative 0.9.
Round to 3 decimal places, so negative 0.900.
What is the p-value? So the p-value.
P-value would be um uh,
Okay,
we
I got
have to use a normal applet thing. Um, um, okay, so okay. Okay, wait.
Do you round it to 3 decimal places?
Yeah, you do. Wait, give me 1 second. Okay, so it is um um so I did the normal probability applet thing and I shaded to the left. And I got 0.1841. So it'd be 0.184. Is that what you got too?
Yeah, that's what I got when I rounded.
Um,
Okay, what inference would you make about the null hypothesis for this problem?
so rejecting the null, this means we have sufficient evidence for beneath. I'm pretty sure because the p-value is less than a certain number. Wait.
Didn't they fail to reject?
Yeah, I think you're right. Because it says because if the p-value is small, um, so if the p-value is small, that means that they reject the null. But if the p-value is large, that means that the c-score is small, which means we can't reject the null hypothesis. So basically, the p-value is small. The null is not true. If the p-value is large, then the null is true. So I'm pretty sure it's failed to reject the null. All right, 3 more questions. Two types of error that can be made. Rejecting the null hypothesis. We went over this. We reject the null when it is at the type 1 error, right? When we know the null is true.
Yeah, you reject it. Yeah, type 1 is when you reject it, but it's true.
Yeah.
So this is type 2. Wait. Failed to reject. So it's type 2, right?
No, it's because type 1 is when you know the null is true, but you reject it.
I thought 19 was asking about what we put for 18. I didn't read it.
Oh yeah, no. So
Rejecting the null when it's true is type 1.
yeah, and type 2 is when we don't you fail to reject the null.
Yeah, but it's wrong.
Yeah. Yeah.
So you should just say that instead of using a level of significance, he'll
Yeah, type
use.
2 is when the null is wrong, but you fail to reject it.
Okay, say that instead of using a level of significance, he will use. Well, he'll be less likely to reject it if it's true. He'll be more likely to think that it's true but not reject it. Is that what I'm trying to say?
Yeah. Yeah, so he'll be, because the level of significance is lower, because the level of significance is lower, then that means the null. Yeah, if the level of significance is lower, that means the null will be false,
Yeah,
which means it'll be a type
2.
2 error. Yes, right?
Because it'll be false, but he won't reject it.
Yes.
Yeah, that's 2.
Okay. Last one. If alpha compute the probability of type 1 error. Isn't it just 0.05?
Well, I'm pretty sure it's 50%, 50-50.
No, I think
Oh, wait, no,
it's
0.05 is 5%.
0.05. I think it just gave us the answer because if alpha is 0.05 and alpha is the level of significance, then I'm pretty sure it's the probability would be 0.05,
Well, I
right?
got nothing else. Doesn't give us anything else, so.
Okay, let's do it.
Okay.
Cool. Got it.
Submit.
Okay, I gotta go though. I gotta get running.
Yeah, I gotta go to sleep.
Okay, you have a good night. Okay, I'll post this link.
Okay, cool.
Bye. I'll see ya.
Bye.